All right, here we go. Unit 6, Day 8, Log Equations, Day 2. Yesterday, we worked on log equations where there was a log on each side of the equation. And so we just got it to a place where we had the same log on both sides, and we got to just set the insides equal to each other. It was just a little trick. Today's going to be much more involved in terms of really understanding how logs work, because we're going to have to convert from log form to exponential form. The way I like to remember it is I like to just kind of get in the habit of I draw this little arrow. And I don't know, for me that little arrow reminds me, oh yeah, it's the base tiny number to the power of what's on the other side of the equal sign equals what's inside the log. So the log base b of a equals c means that b to the power of c equals a. Because remember, this means what power of b equals a, and the answer is c. So the power of b that equals a is c. So that's how you get to that translation. And so what we're going to have today is we're going to have some equations where you have to make that transformation, right? And they vary in difficulty. Some of them, like example number 1, literally is just saying, can you make this conversion? 2 to the third power equals x. 2 to the third power is 8. So x equals 8. Done. And they get harder from there, right? So we'd have some like this, where you just have one more extra step. So 2 to the fourth power is equal to 2x. Well, 2 to the fourth power is 16. And then, again, all that makes this one different is you have to divide both sides by 2, and we'd get x is equal to 8 once again. So same answer there, but different process. These get trickier, depending on how tricky the insides of our functions get. So if we have multiple logs here, right, we have multiple logs that can be combined, we need to combine and then convert. So we combine first. Remember, if we have two logs that are adding, we multiply their insides. This would be x squared minus 3x. All of that is equal to 2. And then we convert 2 to the second power. I'll write it out just to make sure we see what's going on here. 2 to the second power is equal to x squared minus 3x. And from here, this is algebra 2 bread and butter, right? This is what makes algebra 2 different than algebra 1. This is the most important skill, is to just start to be able to recognize when you have an equation in this format that the way to solve a quadratic equation is to move everything to one side, right? We're going to move everything to one side. We do it so that the x squared stays positive. And so what that gives us is 0 is equal to x squared minus 3x minus 4. And the reason we do that is we can then factor this expression. It might take you a little longer, but you'd eventually get to that this is the same thing as x minus 4 times x plus 1. Negative 4 times 1 is negative 4. And in the middle, you have negative 4x and positive 1x. Those would give me the negative 3 in the middle that I want. But the reason we do that is because as long as one of these two parentheses is 0, meaning either x equals 4 or x equals negative 1, if either of those things are true, I don't even care what the other parenthesis is, because as long as one of them is 0, the whole thing is 0. The only thing left to do is check for extraneous solutions. And so you can do that one of two ways. You can either go all the way and checking your work. So let's say if we plugged in 4, we'd have the log base 2 of 4 minus 1 plus the log base 2 of 4, and that would need to be equal to 2. Well, this is the log base 2 of, not minus 1, minus 3 is what that problem said. So this is the log base 2 of 1 plus the log base 2 of 4, all of that needs to be equal to 2. Well, this is saying what power of 2 is 1? 2 to the 0 power is 1. 2 to the second power is 4. Yeah, 0 plus 2 equals 2. Good. But the issue becomes when you try and plug in negative 1 to either of these, you'll get something like this. You'll get the log base 2 of negative 1. This is not possible, because there is no power of 2 that equals negative 1. The only answer here is x equals 4. X equals negative 1 is what we call an extraneous solution. All right, so that's the basic gist of today. Like, you could run with this. I'm just going to work through 2 difficult delta math examples that should help you out today. So just 2 problems to work through. These are exactly, or 3, these are exactly what they look like on the delta math. So level 1, solve for the exact value of x. First step, combine. In order to combine, I need to first bring this 2 in as a squared. So my first thing I would do, this is the log base 7 of 9x minus the log base 7 of 7 squared. And you're free to use your calculator to help you with these. Now we combine these. This is the log base 7 of, if we're subtracting logs, we divide. This is 9x divided by 7 squared is 49 equals 0. And so what this tells us is 7 to the power of 0 equals 9x over 49. Okay, 7 to the power of 0, like anything to the power of 0, is 1. 1 equals 9x over 49. We'd multiply, so you're going to get a lot more kind of funky equation solving practice here today. 49 is equal to 9x. And then finally, we divide by 9. And you're going to have a lot of answers today on delta math that are just kind of weird, because these are generated automatically by the computer, weird fractional answers. So that doesn't mean you've done anything wrong. So one more time, step 1, I brought that 2 in as an exponent on the 7. Step 2, combined 2 subtracting logs by turning them into division on the inside of one log. Step 3, convert the log. 7 to the 0 power is 9x over 49. And from here, it's just some algebra 1. 7 to the 0 power is 1. We multiply both sides by 49, and we divide both sides by 9 to get the final answer. All right, let's keep it rolling. I'll put these up in show notes. Delta Math Level 2. Now we've got one that's definitely going to give us a quadratic to solve. So first step, we combine these. This is the log base 3 of, maybe I work this out somewhere else on my paper. This would be x squared minus 3x minus 5x plus 15. So it's going to be minus 8x in the middle. X squared minus 8x plus 15 is equal to 1. We take that 3 to the first power is equal to x squared minus 8x plus 15. And this is going to be an algebra 2 solve. So we're going to subtract 3 from both sides. That's going to leave us with 0 equals x squared minus 8x plus 12. And so now we need 2 numbers here. Ooh, this is a tricky one. This is my favorite type. All right, so my favorite type, because people look at these and they get stumped for a while. And the reason this one is tricky is when you see that 12, you start running through positive numbers here. When your C term is positive but your B term is negative, that means both of these actually have to be minus, because these 2 numbers need to multiply to make a positive number but add to make a negative. And so the answers here are actually 2 and 6. And so when we use the zero product property, either x equals 2 or x equals 6, because both of those would make the expression equal to 0. And so these are our 2 answers here, but we have to check for extraneous solutions. I like to just look through and see, does it make any of my logs negative? 6 minus 5, that's 1. Nope, good to go. 6 minus 3, that's 3. Good to go. 6 is definitely an answer. But when I go to 2, right, remember I said last time, like, you can't just rely on, is your x value positive or negative? What matters is when you plug in the x value, 2 minus 5 is negative 3. 2 minus negative 3 is negative 1. You cannot take the log of a negative number, so when you plug in 2 for x, both of those arguments would be negative. So 2 is extraneous. The only answer here is x equals 6. All right, last one here today. Last one, just a tricky one here. And again, I'll put these notes up. If I forget, let me know. The log base 5 of 2x squared minus 1 minus the log base 5 of 3x plus 4. So our log rule says this is the log base 5 of, this is going to look like a lot, 2x squared minus 1 divided by 3x plus 4, and all of this is equal to 0. All right, well, I'm going to trust the process. I'm going to convert to exponential form. 5 to the 0 power equals 2x squared minus 1 over 3x plus 4. And so I have 1 is equal to 2x squared minus 1 over 3x plus 4. The trick here is to multiply both sides by 3x plus 4. The reason for that is if you multiply by 3x plus 4 on the right, the 3x plus 4's become 1. They cancel. And so we have 3x plus 4. Let's see, make sure I have that there. 3x plus 4 is equal to 2x squared minus 1. And from here, it's just like we did in the last problem. Let's bring everything over to the other side. So I'm going to subtract 3x, subtract 4, subtract 3x, subtract 4. What that leaves us with is 0 on the left equals 2x squared minus 3x minus 5. And if we factored this is a tricky one. It's not letting me write there. We'd have 0 is equal to 2x and x for sure. And then these numbers need to multiply to make 5, but I need to wind up with negative 3 in the middle. What this is actually going to be is a minus 5 here, so we get negative 5x, and a plus 1 here, so we get plus 2x. And so what this means our two answers are, our first one is x equals 1. Our second one, you might have to do a little algebra to solve this. We want to know when 2x minus 5 is 0. We want to know when 2x equals 5. We want to know when x equals 5 over 2. So our two answers here, before we check for extraneous solutions, are 5 halves and 1. And so again, what we need to just see is, in the original equation, does that check out? Let's check the 1 first. If we check x is equal to 1, well, 2 times 1 squared minus 1, that's good, that's 1. And then here, this would be 7, okay? So this one's good to go. X equals 1 is definitely an answer. What about 5 halves? Well, 5 halves squared is definitely, so it's 2.5 times 2.5 times 2. If I subtract 1, it's definitely a positive number. I don't need to check more than that. And so is 3x plus 4. So both of these count. Both of these would be correct answers. I'll go ahead and post all these to notes so you can use them to reference. Otherwise, that is your task, the Delta Math for today. Good luck on these.